Welcome to the Belmont Forum and the E-Infrastructures and Data Management Projects modules on why data management, how data management, and additional considerations for data management. This is the first of 3 training modules to give everyone some background on the why and the how of data management. This all started with the data deluge. So more work needed to be done as there was more and more data to make that data findable, accessible, and interoperable for reuse by both humans and machines. This overwhelming amount of big data caused a higher need for data management. Data reuse improves and advances science by permitting others to verify results, enabling the repetition of experiments, and to conduct new research. These were some of the primary reasons why data management needed to happen to help advance science. Some more reasons that justify the importance of data management is that data may only be collected once in real time, whether it's surveys of humans or satellite imagery. It's really a snapshot of what is occurring. Data may have enduring value in perpetuity beyond its initial creation. It may have other purposes on longer down the road. You can verify results. This helps in science to do reproducibility. The way to do that is if you have access to the original data and scripts. Data may also be at a global scale. So if you're doing anything that involves collaborating across institutions, organizations, countries, and continents, you're going to need to have data that's managed in a way that it can be shared and then aggregated across that kind of scale. And the big idea is that there will be a lot of new research that's possible through the reuse of data to avoid duplication of data collection. Here's some reasons why data management matters from just a researcher perspective. These are borrowed from Data 1 and their educational modules, but applicable here as well to Belmont Forum researchers, is to keep yourself organized, be able to find your own files and scripts and outputs at various stages of research. You want to be able to track your own science processes for reproducibility. You want to have better control versions of data to make easily identified versions that can be periodically purged if there are things that you will no longer need. This also assists with quality control of your data to be more efficient. You can also avoid data loss by thinking through backups and backups of backups. Also, there's a way to format your data for reuse by not only yourself, but others. It also helps to be prepared, to be able to have some documentation of your data. If you're audited or there's any other reasons for compliance and accountability, you can have that data at hand, ready to share. Gain credibility and recognition for your science efforts through data sharing is made possible and allowed others to cite your data if you share it in the right way and have an object identifier that allows people to cite it. This idea is all built on the idea that for data reuse to be possible, data sharing must happen, and data management enables data sharing that then has data reuse possible. So this data management facilitates sharing and reuse by just having things organized in-house. You're able to share things out of the house. For publicly accessible data, why is this important? Here are just a few reasons compiled by Data 1 from the UK Data Archive. This increases the impact and visibility of research, promotes innovation and potential new data uses, leads to new collaborations between data users and creators, and maximizes transparency and accountability. This also helps to enable scrutiny of research findings, might encourage improvement and validation of research methods, also reduce the cost of duplicating data collection. Some of this data is very expensive to collect, so reducing duplication is one big driver in why publicly accessible data is important. Publicly accessible data also provide important resources for education and training that you can use to inform a new generation of researchers working in an area with real data. The value of data management underscores this concept of information entropy. Information entropy is the idea from Bill Michener and other authors off-cited originally in 1997 to describe that at the time of data creation, at data development, a lot of details are known about the data, but over time things might get lost through the retirement of individuals, changes in careers by researchers on the team, but also details that sort of fall out with just the deterioration of digital data. Here's some examples of data loss that can occur. There could be a natural disaster, a facilities infrastructure failure, a storage failure, server and hardware failure, external dependencies, format obsolescence, legal encumbrance, just human error, or loss of any number of things. And if you've been a researcher for a long enough time, some of this stuff might have occurred in projects you've been a part of, and even if it hasn't happened to you, these are things to consider and avoid to prevent information entropy. Data loss is at greater risk for damage and loss when it's produced by a small group of people or a single person. So sharing your data amongst the team helps to reduce data loss. One study suggested that scientific researchers have a tendency to truncate the data lifecycle and fail to consider steps related to data dissemination, data deposit, data preservation, data discovery, and data repurposing as part of their data lifecycle. This is a historic thing from science that traditionally there was a publication and that's how you disseminated findings. But more and more the ancillary data can also be shared easily through digital means and helps other people validate your findings and have new uses for the same data. Failure to collect details at the time of data creation makes it more difficult for subsequent users to determine the reliability of the data, validate results, and maximize the data accessibility and reliability to duplicate studies. The life of data. So all decision-making gains from a better understanding and implementation of the data lifecycle, which we'll talk about briefly. Historically, the research lifecycle concluded again with the dissemination of findings in a scholarly text. There's an ever-growing extent the published report is accompanied by some supplementary data. Traditionally, researchers were incentivized in the production of scholarly publications, but the data were a less disseminated byproduct of the research, and indeed very valuable and not shared as much. There's been many open movements over time to help encourage data dissemination to improve science by verifying results, enabling repetition of experiments, and executing new research using the generated data. There are many life cycles presented. This is one just of data life cycle from data 1. I'll show first. This is created and has sequential steps in how data is created, collected, assured, described, preserved, and moves through these other steps to become part of research. That one is fine, and everyone has sort of their own. If you want to look through the literature, there's many data lifecycle models out there. I prefer this one from the Digital Curation Center. This model is great because it also has those sequential actions, which are key in thinking through the life cycle of data, but also things that occur not just in stages, but throughout the entire process. This conceptualization is also important to include. It's when first data are thought up or created. This is typically happening well before the research is being done. It's just an idea, but it is important to capture. Also, I like the idea for disposing. Not everything needs to be kept. So many things are sort of de-accessioned or gotten rid of through not kept to the end of a project at least. And the model also has these full lifecycle actions about curate and preserve, which relate to community watch participation, looking out for new emerging standards, other changes in how you curate data, but also preservation planning and looking out for some of those data loss concerns that we talked about earlier, as well as the metadata that allows us to describe and represent information objects. Again, the conceptual part is typically occurring at the proposal, when there's a plan to decide what data will be created and received. Then there's a lot of other thought that goes into the data management plan that relates to how data will, after it's been created, be appraised, selected, ingested, preserved, and stored somewhere. The key today is to think beyond the data management plan and think about the implementation for reuse and perpetuity. These are considerations that people might not have made when originally writing a proposal and a draft of a data management plan. but need to be considered when you think through sharing that data beyond the simple management of it. A data management plan is a structured, formal document describing roles and responsibilities for maintaining and managing data during and after the conclusion of a research project. Such plans may be a requirement of a funding agency. In 2011, the U.S. National Science Foundation and other funding agencies began requiring researchers to submit and execute a data management plan to fully reap the benefits from research investments. DMPs are intended to document data lineage and allow portability, transferability, and future use of data. In addition to funders' DMP mandates, there are many other reasons that we've discussed that focus on trusted, reusable, and stable data. And there's been a rise of various open movements that demand data dissemination to, again, verify results, enable repetition of experience, and execute new research. The Belmont Forum created their own open data principles, and the data should be discoverable through catalogs and search engines, accessible as open data by default, and made available with minimum time delay, understandable in a way that allows researchers, including those outside the discipline of origin, to use them. This is really key for transdisciplinary research. And also, data should be manageable and protected from loss for future use in sustainable, trustworthy repositories. The Belmont Forum Data and Digital Objects Management Plan, the DDOMP Annex, includes some things to sort of operationalize those principles. That DDOMP says this plan needs to ensure that the data is organized, shareable, and reproducible. It helps researchers gain recognition and credibility through data sharing and citation. Also increase accessibility to research outcomes, and it is obviously now a requirement of all Belmont Forum funded projects, including those going forward. So the DDOMP is a guidance document, but like many policies for research data management, is not vague and prescriptive because it needs to work for many different projects. And that action item is what we'll discuss now in the how of data management. For more information, turn to the Belmont Forum Toolkit. There's a lot of data management training materials that are already out there, best practices and standards that already exist, and continue on with how data management in Lecture 2.